This is an intermediate level example for Unity's Graph Toolkit version 0.4. This first video in the series is an overview of making height maps for islands which can be made into meshes. Later videos will cover all the code to implement this graph. The code is available from a link in the description. Graphs can be run in the editor or at runtime from a monobehavior or scriptable object. Changing the graph can only be done in the editor. The graph is an asset and can be seen in the project window. I have chosen an architecture where a scriptable object holds the variables you want to change at runtime. These can be Blackboard variables, such as these four, which are specific to a particular graph. They are reflected in the scriptable object here. The Blackboard feature will change in the future of Graph Toolkit and has some problems now, so my code will change before the release of Graph Toolkit version 1.0. There are some general settings such as size and scale, also noise seed and whether the random seed changes each time, which are needed by all layered noise graphs. There is also a link to the graph. The scriptable object uses this to call the graph and get the returned height map to make a mesh. There's also a monobehavior, which links the scriptable object to an object map holder in the scene and holds a prefab which will hold the mesh. The execution flow starts with calling the graph indirectly from the monobehavior. This calls to the scriptable object, which then calls the graph, sending the Blackboard variables and the common variables. Graph accepts these, runs, and then generates a height map, which is saved in the asset in the project. The scriptable object makes the mesh, which is added to the prefab and placed in the scene. The execution flow in the graph starts with generator nodes. These will generate noise maps, or possibly a constant map in some cases. We'll pass them out through the out port, which is of a type float array. This can be interpreted as a 2D float array. These go to the raise node. Raise nodes multiply all values in the map by a constant. In this case it could be 5, or it can be what is in the value that's in raise cone. These feed into the sum node in this graph, which has 3 import maps which are all summed and passed over to the island node. The island node modifies the height map by looking at the perimeter of the height map, finding the highest point on the perimeter, and subtracting that from all values of the height map. This will put the whole edge of the height map below 0. And this plane here is at level 0. So this will put the edge of the island below 0. Next, the flow goes to the shift Y node, which adds a constant value, in this case -1, to all the values of the height map. This will put the edges 1 unit below the sea level and will give you some space in case you have waves or such. Then it passes to the result map node. There's only one result map node. This saves the height map to the asset layered noise map, which can then be read by the scriptable object. Now, since there can only be one result map node, if you make a second one, you'll get an error. The error will show up over here in the console. It also is passed over to the graph editor, which then shows on the bottom as 2 errors, and you can click through the errors and it will center on the node which caused the error. Now if you save a map with an error in it, the error is saved into the asset down here, and then it will be shown in the scriptable object. In this case, I have made the error very large because it is in red script, and red text does not compress well when going over to YouTube. There are other errors. First let's get rid of this one, and now the other errors. The error goes away. And it comes back here. We'll see this is saved. One of the problems with Blackboard variables that I'd mentioned was that they get erased at times, so have to be re-entered. Hopefully this can be fixed in future versions of the Graph Toolkit. Another type of error would be having no. Here we have none. We get an error. It shows down here. Does not show in the graph window, unfortunately. This is because currently the Graph Toolkit needs you to assign the error to a node to make it show up here. And since this is a missing node, there's no node to assign it to. One thing to note when you're using the Graph Toolkit, it also currently I'm going to use Command Z here to restore this. Note the error doesn't go away. That's because restoring using the undo feature in the Graph Toolkit does not quite work correctly yet. So you have to recreate this node by hand. We'll put it back in here, the result map node, and then relink it. Another type of error that's possible would be cycles. So if you have a cycle in your graph, that will cause an error because these graphs don't support cycles. Doesn't make sense. You'd send the map out, increase it, or raise it, send it back in, and it would just loop. So that produces these two, just like it produces them in the having an extra result node, and you can look through them. I will put this back. Note Graph Toolkit only supports a single node going in to a port, so connecting a different node in deletes the other node that was already, the other link that was already going in. Note that having one thing here is, if we delete this, this does not cause an error. It is fine to have dead ends in the graph. They just won't have any effect. Now for a marketing interruption. If you are enjoying this content, please leave a like. If you would like to see more programming videos like this, please subscribe. If you have any questions, suggestions, or spot a mistake, please leave a comment. If you need some Unity programming for an indie project, contact me at the link in the description. 10% discount on programming if you mention this YouTube channel. And now we return to our regularly scheduled programming. To show what some of these nodes do in detail, I will zero two Blackboard variables here, raise, ridge, and purl, and run the graph. And effectively, this raise, ridge, and purl and noise go to 0. This causes these to 0, which means only this graph comes through. And it says it's a very steep peak constant. So that produces a constant, which is a very steep peak. I should mention that, so inside this standard node, we have the name Then this is an option. Options can only be changed in the graph. They can't be changed. They don't have ports coming in or out. They have to be changed in the graph. In this case, I have a list taken from an enum, which shows all the types of noises that can be generated, including constant noises. So these other ones produce a purlin, and this produces a type of purlin which has been converted so that you'll have ridges in it. The other factors in here, we can see, we'll look at the ridge one, and now they're all ending up below water because these ridges go right out to the edge, and they're the high points. I also have another one, ridge scale, so I can show you what scale does. If I reduce that to say 50, half the size, and I'm going to remove the random feature on here, so it'll use the same noise seed. So even though you have the same noise seed, you'll get approximately twice as many ridges because we've changed the scale for the purlin noise down to 50. If we move it back up to 100, run the graph, it goes back to the previous one. Just to show you how the purlin noise, basic purlin noise works, I'll make that one in here 1. Everything else. It's just very regular noise over the whole thing that can be repeatedly reproduced. And put the water plane back. One other thing that can be done in the editor is you can add or remove Blackboard variables. So I'll just add another, say, float in here. And now I can drag this float into here, and I could hook it up to something. And when I save the map, unfortunately everything gets zeroed. But you can see this new variable is in here, matching this one here. So that variables are reflected over in here. So I will delete this, which deletes it down here. Save it and re-enter this data. So that covers everything that can be done in the editor and finishes my overview. The next video will cover the code needed to implement all this. The code for making all these nodes and generating errors when there is a problem include. Then later there will be code for generating a runtime version of this graph. In this case, I generate matching nodes for each editor node, although this is not a requirement of Graph Toolkit. Also, an algorithm for the topological sort of a digraph will be covered. Then, after that, there is the code needed to execute a graph at runtime, and the ancillary code for the scriptable object, and the mono behavior. Also the code for generating a mesh from a height map. Thank you for watching to the end of the video.